This week there's a lot of new material coming your way, so let's take a look to see what to really focus on. Section 3.1.1. Really look at this section. Notice the use of the EAX register. Make sure you pay attention to the words highlighted in blue. That means they're keywords to MASM. A whole lot like the words int, if, while, and so forth are keywords in C++ or Java. In section 3.1.2, the only integer literals we're going to be using are decimal, hex, and binary ones. In math and computer science, a radix means a numeric base like 2 or 10 or 16. Make sure you realize that if you don't use a radix character, like the H or the B, the assembler is going to figure you mean decimal. From that standpoint, you don't see assembly programmers using the D radix unless they figure they need to really point out specifically that the base is decimal. But be careful. Leaving off the H or B when they should be there will cause you grief and wasted time trying to figure out why your program doesn't work. Trust me on this one. Section 3.1.3, the order of operations for these literals is exactly what it is in high-level languages. Make sure you realize that the mod operator is this one in C, C++, and Java. And remember, literals are just values that are being hard-coded into the program. So if you write all of this expression for a literal, you could just as easily have written -35. In section 3.1.4, just skip it. We're going to be concentrating on integers only for this course. We'll manage to stay busy with just them, I promise. In 3.15 and 3.16, please be aware that there's no difference in single quotes and double quotes for characters and strings. Now that's different from high level. Declaring a string in assembly is equivalent to declaring an array of chars in high level. One thing I will point out, look at how ABCD gets stored as 41 hex, 42 hex, 43 hex, and 44 hex. Why is that? 41 hex is the same as 65 decimal. 42 hex is 66 decimal, and so on. And those 65, 66, 67, and 68 are the ASCII codes for the letters A, B, C, D. Better get used to this hex stuff. Section 3.1.7. You already know what keywords or reserved words are in high-level languages. It's the same here. All you have to do is just get used to a bunch of new ones, and you'll learn these as you go through learning to program in assembly. In section 3.1.8, you're going to see rules that are very similar to what you learned in high level. For this class, please start your identifiers with a letter and make them descriptive. Writing your code in all lowercase works great. Constants you'll probably want to put in all caps. We'll get to those though. Section 3.1.9, know what a directive is. Just like with reserved words, you're going to learn these as you encounter them. Those of you coming from C or C++ backgrounds, which is most of you, notice how similar these are to the includes and defines that are in those other languages. And for now, just know a little bit about the data and code segments. We'll worry about the stack segment later. Which brings us to section 3.1.10. Really concentrate on this section. It's worth going back over several times. It really is packed with concepts that you're going to use in every program you write. Section 3.2 in the reading, that whole section is just going through an example program. For instance, section 3.2.1, make sure you understand what the text is saying about all of this stuff. A whole lot like section 3.1.10, this gives you a lot of insight into what all the parts mean, even in this simple program. The next section, 3.2.2, please watch my video about setting up Visual Studio for MASM. In that video, we're going to create a template to use as our starting place for the assembly programs. And by using that template, just start a MASM project and call it Add To. Then in the source window, type in the program at the top of page 70 in the text, and then just start following directions from that point in the text. I hope you've already used the debugger in Visual Studio in your high language backgrounds. It really is a good one. If you do have experience with it, then the text description of using it will look real familiar to you. Then in section 3.3, we're looking at a series of steps that get your program from source code to an executable file. Make sure you know all 4 steps in this section, including all the parts shown in figure 3-7. 3.3.2. Really study what the text is explaining. Let's take a look at some of the information that it's talking about in this section, and particularly in figure 3.8. First, the listing shows you your source code over here. Then these numbers represent hexadecimal addresses. Notice that the first instruction, where you're moving 5 into the EAX register, that instruction begins at address 0. Keep in mind that all of these addresses will have to be translated by the loader program when it loads the program into RAM in order to run it. Where the program will actually be in RAM could possibly change each time you run it. You really don't know where it's going to load. These numbers are the actual instructions shown in hex. For instance, that B8 is the actual code that says store a literal value into register EAX. The 4-byte, that's a 32-bit, number 00000005 is the literal value being stored. Take a look at the source code. That's what the source code is saying. Look at the first instruction. It takes up 5 bytes. That means the next instruction is going to begin at address 00000005. And this instruction, the second one, takes up only 3 bytes. I know the text is talking about these. I just want to make sure that you're getting what it's saying.